Testing, testing. I'm trying to pick something up. Cat. Unusually repulsive cat. Shame. Sometimes you just have an ugly cat. I don't have an ugly cat, but I have a really smooth cat. I think I prefer an ugly cat. Welcome to the party.
Probably. Yeah.
I had to get security to come unlock the door.
Oh, really?
Yeah, he said he walked by earlier and both of the doors were open. I guess somebody decided to walk through the hallway, close all the doors and leave.
So all you gotta do is just play the Xbox?
My Xbox turns on once in a while, but,
Wait, which Xbox do you have? The X?
huh?
You have the X or no?
I have an Xbox One X, but not an Xbox Series X. And I have a PS4 Pro, but not a PS5. So I am not caught up yet.
I don't know though, even getting a new Xbox with a PS5, I still have the Xbox Slim.
Nothing wrong with that. So do I.
You know, all I have is nothing but, actually it's PC, I'm all PC stuff.
Yeah, I've been doing mostly PC and Nintendo Switch for a while. Just got a Steam Deck, so I got a portable handheld PC, but I haven't quite figured out everything I need to figure out with that thing.
Nice. How much was that? For the gig? What was the gig they have on there?
I got the
What
biggest,
was it?
yeah, I got the biggest one. I think I spent like $700 after shipping.
It's nice though.
Yeah,
Don't get me wrong, it's actually.
yeah. Downside is it's Linux, and I pirate a lot of games, so I'm like, I don't know how to get all the stuff I got on my PC over to this thing. Now I got to figure all that out. And honestly, I just haven't cared lately enough to figure it out. Started a new job about 2 months ago, so I've been mostly stressed with that.
What, the GameStop?
Huh?
GameStop or no?
Oh, no, I left there a while ago. Now I'm working at the plasma donation center over by Target on the south end of town. Hired me as a phlebotomist. Nice and terrifying. Welcome to the party.
Oh, yeah, looks fun in here.
Yeah, it's totally a blast in here. Everybody's happy.
And then Iris is coming. She has to lock her car.
That is perfectly fine. Let's see how many people come back for the second class.
I want to get a valve index, but that's expensive.
Screw that. I have an Oculus Quest 2 for VR. And I just got a third party like beefy cable, plug it into my PC, and I'm like, yay, there's VR. I got it. Cheaper to do it that way. That thing runs on Android, so I did already know how to hack it.
I want the hand sub, but
Oh, that's fair. That's fair. I get that. I just want to play Skyrim on VR and just be like, you know what? This world sucks. I'm going to another one.
That's nice. I got one for my wife that, the Oculus,
Mhm.
I don't get it from my PC. Play it all the time.
The most affordable way to have VR without, hating your life and bills.
These things are expensive. Really.
I got a PlayStation VR and regretted that one.
Why?
It was affordable at the time. I got it for, I think, about 200, all things considered. So it wasn't too bad, but I did not get 200 bucks worth of fun out of that thing.
Wow.
I don't know game on PlayStation. It's good. It's Saints and Sinners.
I mainly would just do like the PS4 version of like Skyrim VR or
Yeah, I guess Skyrim VR, Fallout 4 VR.
you could do No Man's Sky, I think, in VR on PS4 now. But I'd rather play that in PC. So, hello. And you are on that this time.
Okay, thanks.
Oh, hey, it's after 6. How many we got? 5? Cool. Quarter of the class. That ain't too bad. That's pretty bad. I had 11 out of 20 show up on day 1, so I mean, I wasn't expecting much today. Yeah, this class tends to be rough on retention because I mean, honestly, when I was taking classes, if I saw a 2.5 hour math class, I would have just probably changed my major. Like that, this is a lot, but
Same thing when I was taking my IT program, we had to go through calculus. I mean, I was crappy.
yeah,
I was like, why?
yeah, I always appreciated taking calculus here because the instructors here actually have cared generally about the students. And I've actually had some of the best teachers I've ever had in college. I made the mistake of going to Oregon State for a year before all my college stuff, and that was the worst education I've ever gotten in my life.
Oregon.
Yeah, I lived up there at the time, but yeah, no, that was an awful school. I failed college algebra. That's how awful that school was. Here I am teaching algebra. We're doing algebra.
Yeah, I am taking my GED.
Yeah, I respect it. GED is hard. Like if I was looking at if I was hiring and I looked at everything and was flipping through applications, I'd probably respect GED more than Carson High or something. That it's a difficult test. You got to be really willing to put aside those. That's a lot of hours on the test. I think what, like 7-8 hours.
Oh, right.
Yeah. So
7.5, yeah.
How many questions have you?
a bunch. I am bad at the GED stuff. I'm good
We
at
have
the
like 4 tests, right?
yeah, it's split up a couple of different ways.
Four tests, 2 hours each.
I believe I actually had.
I think the math is 2.5.
Oh my God.
You got this. Where?
Putting in hours, you're gonna pass, yeah, I know, you're putting in hours.
Like math, I don't understand. You're one of the smart people.
You'll be fine.
I don't understand anything more.
That's okay. Neither did I when I was taking it. I had no idea. Honestly, the best thing I ever did for learning math was tutoring, because up until when you're taking the classes, you're like, oh yeah, I learned this year, I learned this year, I learned this year, and they're all separated out subjects. But when I started tutoring, I was helping everybody in a bunch of different classes all at once, and it kind of like clicked in my head where it's like, these aren't separated course materials. It's all one big ugly thing. So it ended up, working out a little bit better in my head that way. Trying to find, I know at some point I had a sheet that had the difference between the two tests.
I used to have a VC.
Yeah,
Yeah. And it fried itself.
it does some suckers out. You don't want them to choke themselves to death. That's when I was working at GameStop, a lot of people would bring in their systems like, this doesn't work anymore. And I would just, we had instead of compressed air, we had this like blower thing, which honestly, they ended up with 2 at one point. And now there's 1, let's say it that way. But yeah, I would put their system down and I would blow into this thing with this blower, and this room would fill with smoke. Like the amount of nasty that people have in their systems and stuff.
I clean that thing out every day. I
Really?
used it, yeah.
Yeah.
But I think what happened was the thermal paste was really cheap.
Oh yeah. You don't cheap out on thermal paste.
I think the person that built it for me cheaped that on thermal paste.
There is a difference of like $10 between garbage thermal paste and top of the line thermal paste. Anybody that cheaps out on thermal paste.
So it worked for like about 3 weeks, and then I was like, it's just stopped working. I was like, what's happening with it? I tried to recoat the thermal paste and everything like that, because I figured out that it was all dried up on it.
Oh God. Oh yeah. So your computer literally just choked itself to death. Cool.
It was $1,100 too.
Yep. I would have sued that guy.
He moved to Texas right afterwards.
That sounds right. Okay, so today we're gonna finish the fraction stuff. We got a lot of fraction stuff. I have a ton of examples of fractions because I know you guys hate them. And the only way to get past hating them is to do a bunch of them. Then it starts to click and you hate them a little bit less. And you get to the next step in math and you're like, oh man, I wish I was still doing the fractions. And that's kind of how math works. You hate it until you move on, and then it all sort of kind of builds. So chances are everyone's going to hate this class for a couple of weeks. How it works. So in terms of review, I don't have any problems to put on this. I just wanted to stick it back in your heads. You know, the real number system, we have the natural numbers are your regular counting numbers that are positive. Whole numbers starts adding at 0. So you have 0, 1, 2, 3, blah, 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 blah. Integers adds the negatives, and you'll find yourself using the word integer most often because, I mean, it's basically all your round numbers. So it's all the negatives, it's 0, it's positives. You're going to use the word integer most often. And rational just means that they're not irrational, pretty much. It's literally everything that can be written as a ratio. Ratio just being a fraction. Irrational numbers are the weird ones. You get a lot of roots in there. It's not just square roots. You'll have cube roots, fourth roots, fifth roots. When we get to roots, I'll show you a fun way of dealing with them that I hate how they teach roots in school because honestly, it's not that bad. The way I teach square roots and cube roots, you can scale up and do like a 500th root and it'll work. It's not bad. It's just, yeah. I hate how some of these things are taught. All right. So yeah, that's pretty much it for the real number system. I think we're feeling good on there. Then we have the number properties. Instead of like 20 slides last time. Here's everything all at once. Nice thing about being able to see everything all at once is that you can tell the difference really cleanly. Commutative properties. Slideshow so quick. I decided to do bright background today instead of dark background because the first class I was kind of shooting for assuming I had a projector and I didn't want to blind everybody. And then I figured out it's a dark monitor. With terrible viewing angles. Hold on a sec. This looks better. Let's play with this. Oh my God, is that really? That's seriously the brightest it gets. Okay, cool. All right. Probably a little easier to see now. Okay. So we have the commutative properties, associative properties, and the distributive property. Both of the commutative and associative deal with addition or multiplication. Commutative, if you remember, it just basically means these are things you can rearrange and you still end up with the same thing. Associative means these are things you can group differently and still end up with the same thing. So you can see that if everything's added together, it doesn't matter how you shuffle things around. It doesn't matter how you group them. They work out really nicely either way. Same with multiplication. If I have the same things all being multiplied together over and over, well, then it all ends up being the same thing. So it doesn't matter how you associate them together. It doesn't matter where you move them, as long as they're kind of on the same plane. That mostly gets into the order of operations, which, you know, thinking about it, I probably should have gone into, but I think I got some problems for this thing that that'll cover that real nicely. Then we have the distributive property, which is something that you can use very well, and we're going to use for good with algebra. If you have something outside of a set of parentheses, it basically just means that you can distribute it through. Likewise, it also works. I'm glad both of you made it to class. We are now at what, 8 out of 20. You know what? That's better than 4 out of 20. So yeah, cool. But yes, remember that the distributive property can be used backwards. So if you have the same thing multiplying onto multiple little pieces, you can pull it out and just add the pieces together pretty nicely. Sometimes that works out great. Sometimes it doesn't, but you know, we run into those, and that's why you learn a bunch of different ways of doing a bunch of different things, because sometimes it works better one way versus another. How about we do some problems? Now, the first one here I set up as a multiple choice. Multiple of them are the answers. But the idea I have here is, which of the following obeys commutative law? So basically, which of these, if shuffled around, if turned backwards or whatever, gives you the exact same thing. So looking at A, 3 times 12, is that the same as 12 times 3? Yeah. So then yes, that one obeys commutative law. So A is one of our answers. B, 4 plus 20, is that the same as 20 plus 4? Yeah. So commutative law, check, cool. C, 36 divided by 6, is that the same as 6 divided by 36? Oh God, no. And if you think it is, I'd love to borrow money from you. So yes, like I've pointed out, commutative and associative, they deal with addition and multiplication. With subtraction and division, not so much. You can get away with it with subtraction. You just have to keep in mind that wherever that minus is, that negative, that has to stay with that number. So you can move them around in that case. Like D here, 36 minus 6. That one's a little tricky because does it obey commutative law? It depends on how you do it. 36 minus 6, is that the same as 6 minus 36? No. But if you keep that minus with the 6, and keep in mind, okay, 36 and minus 6, that's you putting two things together, right? So you could write that another way as negative 6 plus 36. If you keep the symbol with that 6, then it does obey commutative law. And that's actually something I think I'll probably cover here randomly on the notes. Is the order of operations real quick, because I also hate how that's taught. And then E, we have -3 times 4. Is that the same as 4 times -3? Again, yes, as long as you keep the negative symbol with the correct number, then you're good. That 3 isn't going to magically lose the minus on it if you move it around. Same as with B, with that 6, it's not going to move the minus, lose the minus if you decided to move it around. 36 minus 6 is the same as 36 plus a -6. Good. And number 2, which property is applied to the expression 5 plus 3 in a parentheses plus 12 is equal to 5 plus 3 plus 12 in a parentheses? So is that commutative or associative?
Associative.
Or correct, sir, because we're not moving where they are, we're changing how they're being grouped. Now, this is a dumb part, but associative property of what? Addition, right? Because it's all addition. Any math book you look at, any math test you're going to look at, it's going to ask you for, which property it is. You're not going to be able to just say associative or commutative because they're all separate properties. Associative property of addition, associative property of multiplication. They're separate laws. I like to teach them as kind of the same thing because honestly, they make more sense as the same thing. But they are specific on what they're looking for. And then the last one, that one I decided to have some fun with. That's going to be the one I write down. This is also going to be a nice little aside for the order of operations. You'll notice that I have an asterisk on the page where I'm implying multiplication. And I have a slash where I'm implying division. That is purely because it is so much easier to type that way. But they do mean the same thing. Let's switch over here. So the problem is 5 plus 3 times 2 plus 14 minus 8 divided by 4. Just started typing random numbers on the page and then I put symbols between them. And I was like, yeah, okay, that's good enough. So here's the thing. We want to write this in some different ways. Now, one of the things that, I'm gonna stress it a lot. I don't like how math is taught. They'll give you simple things like, oh, 2 times 3 is the same as 3 times 2, right? Okay, cool. Now apply it to a big, ugly, giant thing. And you're like, wait, everything I've done so far, every example you've shown me has 2 things in it. Now you want me to figure out what's going on with 7? Not exactly the nicest way of teaching math, I think. So that's why I decided to do this problem because, well, there's a bunch of different ways I could write it. And it's not just 2 things, we have a ton of different ways I can write this. I'm not going to write them all because I don't honestly think I could name them all. And if I really wanted to, I'm sure as heck not going to exhaust that here. So what I want to stress is the order of operations. Now, that's another thing I've never been a big fan of because it's been stressed as being this really strict, stringent thing, and I like breaking. I like breaking the order of operations because sometimes you can do things a different way, and it's really just a guideline to make sure you don't make mistakes. So if you remember, one of the main ways that order of operation is written is PEMDAS. Anybody know what that stands for? No? Cool. I like it about blank slates. Blank slates are great. That means I don't have to take something out of your brain that's broken and fix it. I get to just put new stuff in there. So it's always parentheses, exponents, which we'll do later, multiplication, division, addition, subtraction. So it's kind of a guideline on an order of operations to do to make sure that you don't break stuff. So really it's all about just not breaking math. We don't want to break things. We don't want to have invalid operations. So the main idea, and this is, let's see if I can, I'm going to make up a random problem that we're not really going to work out too much. Say I had, I don't care. Let's do that. Let's say we have something where just about everything is represented, right? Actually, there, I put a -3 at the end. Now it's everything. All 6 of those options are there, right? Parentheses, exponents, multiplication, division, addition, subtraction. Let's look at the order of operations and figure out, hey, why is it in this direction? Because honestly, it's annoying to memorize. It's annoying to memorize things. I have a terrible memory. So if you just understand why it works, usually it clicks a little better. So parentheses is first. Why? Well, if I looked at this big ugly thing, I can't really multiply the 5 into this. I can't distribute it because, well, it has an exponent. So this exponent here is saying that I have this set of parentheses twice. Now, let's not stress that right now. We're going to do exponents on its own day. But basically what that's telling us is that this parentheses isn't just a thing, it's raised to a power. So I can't play with the 5 yet until that's dealt with. Well, I can't really deal with this 2 until this is cleaned up, right? Like this 4 plus 2 is kind of messy. I could easily put those together, right? Well, that's why parentheses is first, because it's kind of the innermost thing. It's the first thing that you can actually get away with cleaning up safely. So on a problem like this, you would be able to clean this up. I wouldn't be able to divide this big ugly thing by 3 because I don't know what the heck number this is. I really don't. I just threw these numbers on the sheet of paper here. I have no idea. So I can't subtract 3 from it yet because I don't know what this is. I can't divide it by 3 because I don't know what this is. I can't multiply this by 5 because I don't know what this is. So it really boils down to you're going kind of the furthest in to work your way out. So you'd be able to deal with this. You figure out that's a 6. Okay, cool. Can I say 5 times 6? No, I can't say 5 times 6 because that's not a 6. That's a 6 to the power of 2. So that's why exponents are second on our order of operations, because that's not a 6. It's a complicated thing. So you clean this thing up to make it less complicated, and then you deal with this and make it less complicated. Well, 6 squared, that's 36. Okay, so let's make another line here. Can I divide by 3 yet? No, because I don't know what the heck this is. Can I subtract 3 yet? No, because I don't know what this is. So again, we look at our order of operations. Now, multiplication and division are a little tricky. What I like to teach is that multiplication and division and addition and subtraction are kind of on their own level. Multiplication and division are on the same level. Addition and subtraction are on the same level. That's actually a big problem I have with how this is generally taught, because you would look at this and you'd say, oh, multiplication has to come before division. No, because let's go back to the other day when we were talking about dividing fractions, and we talked about how dividing fractions sucks. So we're not going to divide fractions. We change it to multiplication, right? Well, the thing is, multiplication and division are kind of the same operation. If you're dividing by something, if I'm going back to the example I have of taking $2 and divided by 50 cents, you are dividing that by 1/2, right? So we change it to multiplication and it ends up working out the same, because division is actually the inverse of multiplication. Is that important to know? It's not important to wrap your head around, other than knowing that these guys are on the same level. But it's basically the same as saying that 5 divided by 2 is the same as 5 times 1/2. Multiplication and division are on the same level because they're kind of the same thing. Same with addition. Going back to that one we did is where it was 36 minus 6, right? That was pretty clearly a subtraction problem. Well, I said that it could also be written as 36 plus a -6. So again, subtraction is adding in the inverse. So addition and subtraction are on the same level, the same way that multiplication and division are on the same level. Now, in a problem like this, you basically have to think, okay, what's the next thing I can get away with? Now, there's actually a couple of ways to do that. I could multiply that 5 by that 36. That's valid because I know that the top here on this fraction is a thing. And that thing is 5 times 36. I could also say, hey, well, if multiplication and division are on the same level, I could write this a bunch of different ways. 5 times 36 divided by 3. I could do that part first, right? If multiplication and division are on the same level, I could just say, hey, wait a minute, like any reducing fraction, I could reduce that. I could say that this was 5 times 12 right now. I could. Did I just do this one before I did that one? Oh yeah. Can I get away with it? Oh yeah. And that's why I don't like how this is taught. These are on the same level. Now, can I play with this -3 yet? No, because I have no idea what this is. We have to have a solid number to know what the heck that is. And real quick, let's just, because 5 times 36, I don't want to do that. But 5 times 36 divided by 3, oh yeah, I totally want to do that. That's a lot easier to do. 5 times 12, that's a 60. 60 minus 3. Can I get away with doing the -3 now? Yeah, right? So what I kind of do, how I like to explain it is when I have a big, ugly, weird looking thing, I almost kind of look at those two symbols and I say they're separators. I say they're separators because I can't take this 5 and add it to this because these two have to happen first. That 3 times 2 has to happen first. I can't add the 14 because this isn't a 2. This is a 3 times 2. So what I like to do, this is kind of how I like to visualize it. Rewriting the whole thing. Anytime I have multiplication and division, I keep in mind that's a thing, right? That's its own thing. That's a thing. All those pluses and minuses, that's where my separate terms are being separated out. So I have, despite the fact that I have 6 numbers here, the multiplication and division is making these like one portion. So as long as I separate things out and move them around based on that, I'm good. What are a bunch of different ways I can write this? Well, if I'm saying that I'm separating those out, here's a good application of the associative property. I could write it like that. I could put the parentheses around the things that have the multiplication and division, and suddenly it's an easier to look at problem, right? They're not all stuck together. They're not all kind of their own deal. We can actually see where we're looking at this. We could leave those sets of parentheses and move things around. What if I decided I wanted to have the 14 and the 5 next to each other because I know that those guys are going to add up nicer? Now, is this 5 positive or negative? Positive. So kind of gains that plus, but it's just, we're keeping in mind that that's a positive number. And then we have this 3 times 2. And we have this 8 divided by 4 over here, but it does have a minus out front of it. So if I decided randomly that I was going to rewrite this a different way and have that thing out front, I can't just do that. That minus either has to go with this whole thing or just on that 8. Now, why is that? Well, if you remember, if I had a 2 over a 1, but it was negative, that's exactly the same as a -2 divided by 1 or a 2 divided by a -1. That negative can kind of move around. So if I looked at this division and said, well, that's kind of a fraction, that negative just has to stay with this. Doesn't matter if it's with the 8 or with the whole thing combined. So I could do that. I could even take that parentheses and put it out front if I wanted to. There's another way of writing. There's another way of writing. What else can I do? I could make a random example and say, hey, well, let's keep this a -8. Let's break what this looks like a little bit. If I'm dividing it by 4, that's the same as multiplying by 1/4. I could do that. I could drop that parentheses. I don't care, add these guys together. I don't care what the answer is here. It's all about being able to understand where things can move. Yes, and the dot, again, the dot is a symbol for multiplication. The slash, that's actually a symbol for division. Same things. So do I care what the answer is here? No, I care about whether or not you understand what you can move around and where. So that was its own kind of little mini lesson on the order of operations. And you'll see me kind of break the order of operations as time goes on because it's a guideline, not a rule. But if you're confused about numbers and you're like, oh God, what do I do? What do I do? It's a great guideline for keeping it straight. Any questions? Anything wildly confusing and horrible and you're like, oh God, what's happening right now? Okay. How's that for a review problem, huh? I stretched that sucker out good. Okay. So that was all I got for the review. Now we're going to look at some more stuff with fractions. Everybody online is just seeing black boxes move around this right now. Okay. So, new stuff. We already played around with a little bit on improper fractions, multiplication, division, all that stuff. Let's look at actually using improper fractions and mixed fractions. So in order to be able to use mixed fractions, you got to be able to convert back and forth between them. So converting two mixed fractions is actually really easy. It's a weird looking sentence I got down there at the bottom, but all you really got to do is you divide the numerator by the denominator. So you divide the top thingy by the bottom thingy. You take note of any remainder. And you say, okay, well, how many times did that go in? Well, 13 divided by 7, for an example. Well, 7 would go into 13 once, right? And then it'd have a remainder of 6. So you say, okay, 13 over 7 is the same as 1 and 6/7, because the remainder, that 6, didn't go in evenly. So it's still in that fraction. So you're basically taking the part of the fraction that's the whole numbers and taking them out. Now, the other way is kind of weirder looking to write down. It'll make a little bit more sense when I write down some of the examples in the notes. But converting mixed fractions to improper fractions is easier. There's actually what I have written here is actually kind of a shortcut way of doing it. What you would normally do is you would look at it and say, well, if I have like, say, 2 plus 1/4, and if I was adding those two things together, I would say, oh, well, I'm adding a fraction and a whole number. So I would get a common denominator between them, and then I'd add a cross, right? That's all you really do. Is mixed fractions are really, it's literally 1 and 6/7. Mixed fractions are weird to work with because it's the same as 1 plus 6/7. It's two separate numbers being attached to each other. So in order to convert out of it, you would actually take your integer, the whole number, and you multiply it by the bottom of your fraction. So if I got 1 and 6/7, I would say, okay, I'm going to take the 1, I'm going to multiply it by the 7, and I'd say, okay, I have 7. Take that and add it to the top of the fraction. So, okay, I have 7, I'm adding 6 to it, that's 13. You put it back on top of the fraction and you call it good. So that's kind of what's happening there in the middle. I have 1 and 6/7, and I say that the top there is going to be the 1 times the 7 plus the 6 that was already on top. So again, if you're lost, because honestly, this is a weird looking slide and I wouldn't be surprised if everybody's lost right now. But you would convert your whole number part to a fraction, get a common denominator, and add it to the 6/7 like any other fraction. But this is just a shortcut. And I'll do a bunch of examples on that, so not too bad. Speaking of, hey, look, examples. I love examples. So we're going to convert to a mixed fraction. We have 12/5. Okay. Oh God, what do we do? Oh God, what do we do? Well, it's not too bad. All you gotta do is say, okay, well, how many times does 5 go into 12? Twice. What's remaining? I pull out that the 2 5s. What do I got left out of the 12? Yeah, we have 2 left. So the part that's left goes on the top part of the fraction. You keep the same denominator. And that's it. That's all there really is to them. We'll do a couple of more though. Okay. 14/3. What do we got? 14/3. How many times does 3 go into 14? 4 times, right? Because 4 times 3 is 12. 12 goes into 14, so that leaves 2 left over, right? So 2 are left over. That part's still over the 3. Now, just for you guys' notes, I'm going to show this a little bit of a longer way, just so you can, you know, worst case scenario, say, okay, I got this now. So what we're actually doing is we're kind of splitting this up as 2 separate pieces. So we're taking the part that goes in evenly, we're taking the part that doesn't, we're cleaning them up a little bit, and we're saying, yay, this is a number. The fact that this is equal to that is why I hate mixed fractions. Because this is really hard to do math with. It's treating these 2 numbers that are added together as one thing. Really easy to break. Okay. 50/7. Well, 7 times 7 is 49, right? So 7 goes in there 7 times. 49 out of 50, we got 1 left. 7 and 1/7. And one more. We have 35 over 6. So you look at that, say how many times does 6 go into 35? Well, 6 times 6 is 36, so not quite that far, so one less. So 5 times, right? So 5 times 6 would be 30. So I know this went in 5 times, but at 30 out of 35, I still have that 5 left. So we have 5/6. Questions, comments, concerns, confusions? Everybody happy? Everybody kind of not happy? You'll get happy eventually. We got this. We got this. It's gonna be all right. All just converting from one type of fraction to the other.
They're saying the 6 fits are the 5 times. Right?
You're saying that the 6, you're saying, okay, how many times does 6 go into 35? Obviously, it doesn't go in evenly. So you'd say, okay, well, it would go in 5 times. So you would have the 30, right? Because 6 times 5 is 30. And we're splitting that up. So we kind of have the part that goes in evenly and the part that doesn't. The part that goes in evenly, that guy breaks down to a 5. Because 30 divided by 6 is 5. And the part that doesn't, that just kind of hangs out. That stays there. So all we're really doing is we're separating this 35 out. We're saying, okay, we need the part that goes in evenly and the part that doesn't. And I'm moving windows around so I can see. Now we're going to go the other direction. Let's go the other direction. Oh man, if I knew I was going to do this, I probably would have not quite used all that room. Okay, so convert the following to improper fractions. So for number 1, we have 2 4/5. So this way we're going the other way around. Now, the easy way of doing this. Oh, hey, that's where I put my name tag. I just found it in my pocket. Hello, little fellow. Yeah, I had no idea where this went after the other day. Cool. All right. The 2 4/5. So it's kind of weird to do, so you kind of got to watch it. What you end up doing is you end up saying, okay, take this whole number, multiply it by the 5. So the whole number part times the denominator. And then whatever that is, we're going to add what was already on top. And then you keep it as the same denominator. So normally, you don't really have to show a whole lot of work for something like this. You would say, okay, I have 2 4/5. Okay. 2 times 5 is 10, plus 4 is 14. So that's what you do on all of these. You really just take this whole number, multiply it by the bottom, and then add that to the top. A really quick method. Now, again, if you're a little thrown off, you can keep in mind that the reason I hate mixed fractions is because they're basically 2 separate numbers. This is basically a 2 plus a 4/5. So worst case scenario, you're taking your test, you're doing a word problem and you're like, oh God, in order to do this word problem, I have to get out of mixed fractions into improper fractions in order to actually solve it. And I don't remember what that weird guy was rambling on about that day. Well, worst case scenario, you take the 2 4/5, split them up. Call it an addition problem. Anytime you're adding a whole number to a fraction, you can actually put that whole number over a 1 and then just work it like any other fraction problem. So you could look at that and say, okay, I have 2 over 1 plus 4 over 5. I was getting a common denominator between those. Between 1 and 5, it'd have to be 5, right? You multiply this one by 5 over 5. Go over and say, okay, we have 10 over 5 plus 4 over 5. We can add across on top now. So that's 14 over 5. Well, what did I just do? I just said this number times that. And that ended up being a 10. And then I added what was already on top. So all this method I have here is just the operations you would do here, but just doing them right away without writing out this whole big ugly thing. So this is probably not something you're going to see in a math book, but it's the way I like it. A little easier.
Actually, that was on some of the pre-test.
This particular method. Oh, cool.
The bottom, actually, the bottom. Is
Oh, this thing?
Yeah, exactly.
Yeah, exactly. So yeah, this is how they expect you to convert from a mixed fraction to an improper fraction. But if you look at what it is you're doing, you're multiplying that by the denominator, you're adding it to the top. So why not just do that right here? Why not say, okay, I have 2 4/5. I'm going to take this. I'm going to multiply those together. And then I'm going to go over here and I'm going to add it to that. It's just kind of a loop. This is why I didn't write this out this way in the notes, because if I put this on a sheet of paper and put it in front of you, you would be busy. This kind of looks horrible on its own, right? Like, what the heck is going on there? But yeah, just multiply onto the bottom, add to the top. The question is, how quick can we do number 2? 6 2/3. All right. Follow this method. Multiply down. 6 times 3 is 18. 18 plus 2 is 20. Cool, we're done. Effort. 3. 14 3/10. 14 times 10, 140. I love multiplying things by 10. You just slap zeros on them. So 14 times 10, 140 plus 3, 143. And it's still over the 10. Then we have a fourth. This one is 13 7/11. Who knows what 11 times 13 is? Cool, me neither. All right. Yeah, you thought I was smart for a second, didn't you? No, I just know a bunch of tricks on this stuff. Embrace the calculator. 13 times 11. 143. Awesome. Okay. 143 plus 7. 150. So again, I'm gonna write that out kind of a long way just to kind of round off this problem. We did 13 times the 11, then we added the 7 to it afterwards. If you're on the test, you're like, oh God, what do I do? Take that, multiply it on there, add that. That's the numerator. Isn't that fun? like somebody probably spent like an hour explaining that somewhere and just confused the heck out of everybody. Any questions?
They're not to use calculator on the test now, right?
Yeah. Yeah, you absolutely can. Yeah, that's why normally when I teach this class, like the first 2 weeks are me, or first week is me going over addition and subtraction and multiplication and division in like incredibly awkward ways, torturing everyone with long division. And I'm like, you know what? You're all gonna have a scientific calculator on the GED, so use it.
They make this.
Yeah, 100%. Yeah, whole time.
That's an
Why
onboard.
would it use it? Like,
Well, say you're doing math at work and you had to multiply two numbers together. Are you gonna pull out a sheet of paper and start writing, or are you gonna grab a calculator?
calculator.
There you go.
Uh,
Yeah,
but
and
is that cheating for them? Like,
No.
No?
no, yeah, it's
Okay.
fine. Yeah, I mean, being able to do that stuff on paper, one, is a good skill to have. The last time I actually taught this class, I realized that I hadn't done that in a couple of decades. And I was like, oh God, I can't add on paper. I can do calculus. I could do differential calculus all day, glancing at a book and being like, yeah, I could figure this out, no problem. But I couldn't add. I couldn't multiply. I couldn't divide.
I can buy the one you send me the email, the $14 that you get.
Oh yeah,
I can buy that one, right?
yeah, that's a perfect calculator.
You send me one sample, like the one I can buy.
I
How that to answer?
oh, you're good. You're good.
I can buy, you
I'm-
send me one.
I am god awful at remembering to check my email and then reply to my email.
Yeah.
You
send me one, like, I think it's $13 on Amazon.
Yeah. So what I'm talking about here, we had a discussion on calculators.
It's hard to- I don't know, if there's a whole bunch of art.
I literally just typed scientific calculator on Amazon and I'm like, that's too pricey. That's too pricey.
That's what I
Hey,
got.
look, that one went down to $10 today. That's
Okay.
interesting.
The same you send me?
Yep.
Oh, okay.
If you already bought it, send Amazon a message and they will probably refund the difference.
No, I haven't buy it.
Okay, yeah, because it varies, but this is pretty much like the standard of scientific calculators.
Oh, okay.
First of all, Texas Instruments has a ton of money, and that's why you'll see Texas Instruments calculators recommended in most classes, because they just shove those onto everybody. And yeah,
Yeah, I'm gonna buy that one.
yeah, because I mean, at the end of the day, for harder stuff, like when you get to calculus, graphing calculators are useful. Which apparently are getting cheaper nowadays. That's kind of cool. But I mean, you know, you're looking pretty pricey. Yeah, I have no idea how much the one I have is going for anymore. If they even, you guys still make it?
Yeah.
Hey, there it is.
Yeah.
Hello, little fella.
Oh, $100 good.
Yeah. That's what I got. But you know what? This thing has lasted me.
$9. That's good for calculus too.
The scientific calculator, it can be. When you're doing graphs and stuff, it's good to have a graphing calculator. But a lot of those are getting obviously cheaper now, apparently. So, you know, there's no reason to spend over $100 anymore. But yeah, this thing was like 150, I think, at the time. And I mean, I've been using it for like 17-ish years.
Wow.
So my calculator would be able to vote soon. So you know what? It's gotten its money's worth. Already on this, yeah. All right. But yeah, when it comes to calculator usage on the HiSET and GED and stuff, I actually think what my department has is like a little caddy full of yellow ones, just to be able to pick them out of a crowd. But I'm pretty sure it's that model of calculator. So it's literally, it's the standard. You can do everything you would need to do it all the way up through trigonometry. I think in trig, I actually got a graphing calculator, and that was less because I needed one and more because I realized it would make my homework easier. So, yeah. So let's get on to operations with mixed fractions. So as you can tell, it's easy enough to perform operations with basic proper fractions or improper fractions like we did the last class. You know, adding, get a common denominator, multiplying, multiply across, dividing. I don't want to, you switch to multiplication anyway. But how do you work with mixed fractions? Because like I was saying last time, like if somebody tells you that something's 13/7 of a mile down the road, you're going to slap them, you know? You don't want to hear that. You want something that doesn't sound stupid. So usually with word problems, you're going to be doing, or at least answering in mixed fractions. And they might give you problems with mixed fractions in them already. And you'd be like, okay, well, how do I work this? And my big problem with mixed fractions, as I've said, is because like I have written here, 1 2/3 is the same as 1 + 2/3. They kind of have an operator between them, even though it's not written. And that can really mess you up if you're doing math. So the whole idea with, you know, you look at any math book and you look at how to work with mixed fractions, literally all they ever tell you is convert it to an improper fraction, do the math, and convert it back. That's why we had the last 8 problems, because I mean, with word problems, that's what you're going to do. You're gonna take a mixed fraction, convert it to improper, do a bunch of math stuff, whatever the heck it is you're doing, and then at the very end, when you have to answer a word problem, you know, if you remember, at least in my experience in elementary school and high school, I wasn't allowed to answer a word problem without a full sentence. If you're saying something out loud to somebody and you have an improper fraction in there, it just sounds weird. So usually switch it back to mixed fractions. So lots of fractions. Love fractions. We're going to do so many fractions. We got these 4 problems. Then we got another 6. And then we got a couple more terms that deal with fractions, and then we'll be done with fractions. Lots of fractions. You're not going to hate fractions by the end of this class. That is my goal. So,
Get ready to do them.
yeah, that's okay. That's why I'm doing them. Because everybody hates them. So, this says Linda. You ever notice everyone has an Aunt Linda? Does anyone have a mom Linda? Linda, a mom name? Linda's an aunt name. I have an Aunt Linda. I've met tons of people with an Aunt Linda. I've never met someone named Linda with their own child. All right, so Linda walked 2 1/3 miles on the first day and 3 2/5 miles on the next day. How many miles did she walk in all? All right. That's actually, you know, conceptually, that's not too bad. You're adding a couple of numbers together, right? There's actually, we're going to do this the way we're supposed to do it, but I'm going to show you something horribly cheap at the end of this on how to do this. Horribly cheap. If you do it in front of a math teacher, they'll be like, the heck was that? But we're asked how many miles did she walk in total? So we got 2 1/3 plus 3 2/5. Well, I can't really add those together right away because 1/3 doesn't combine nicely with 2/5, and you know they're mixed fractions. They're kind of weird. So we have to convert them to improper first. So we're going to take the 2. Multiply it by the 3, so 2 times 3 is 6. Add to the top, 6 plus 1 is 7. So this is 7/3. Plus Exact same idea. We have 3 2/5. We're going to convert it to improper. So 3 times 5, multiply the whole number, the integer, by the denominator. 3 times 5 is 15, plus 2 is 17. All right, so we have 7/3 plus 17/5. Not the prettiest numbers in the world, but it's something we can actually work with now, right? So if we're adding two fractions together, we need a common denominator, right? So you think, okay, well, what's the first thing that 3 and 5 can go into? When they're nice little numbers like this, you can multiply them together and usually get what you're after. So 3 and 5, that would be 15, right? That's actually the first number that they go in, both go into. If you start having larger numbers, weirder numbers, that's where getting a common denominator gets a little trickier, and we will cover that in a future class. But for now, all it really is just look for the first number you can think of that 3 and 5 both go into, 15, right? So we're going to multiply this one by 5/5 and this one by 3/3 in order to get our common denominator. So 5 times 7, 35. 5 times 3, 15. Now, one thing I do want to mention is that personally, I like to multiply I know that both of these are going to end up 15, but I do like multiplying them and actually doing that work, because if you're on a test and you write 5/5 and like 3/3 here, and you write something over 15, over here you end up with something over 17, you can be like, oop, something went wrong. So it's just kind of a nice check to make sure that you didn't break math. So I know that this is going to be 15, but I'm still going to end up multiplying those two numbers together just to make sure I'm not making a mistake. 17 times 3, anybody know? Yeah, exactly. You don't do that too often, right? Unfortunately, I do, and it's 51. Is that me being good at math? No, that's me multiplying 3 times 17 over and over for many years. You don't know it, grab a calculator. Okay, so now we can add across. 35 plus 51, well, that's actually not bad. 3 and 5 is 8, and 5 and 1 is 6. Neither one's over 10, so I don't have to like carry any numbers or anything. Just add up the digits. So I end up with 86/15. Okay, how many miles did you walk in the last couple of days? 86/15. What? That's not a good answer, right? So every time you do a word problem, what I tend to recommend is, if you take what your question is, answer it to yourself with the answer you have written and see if it sounds awful. If it sounds awful, you probably either made a mistake somewhere or you got to fix something. I'll always remember when I wasn't quite as good at math and I was in a physics exam and I was having to use a formula I hadn't used in years. And it was a question of how long a purse would fall out of an airplane. How long would it take at like 10,000 feet or something? And I screwed up the math and I said 0.0001 seconds. So that thing just became a crater and killed all of civilization. That thing just teleported. So I made a horrible mistake. I looked at it and I didn't know how to fix it. And yeah, but I could recognize that the answer was wrong because I said it out loud, or said it to myself in that case, and was like, yeah, this is a terrible answer. So 86/15, this is the first time we have to convert back to a mixed fraction, and our numbers kind of suck, right? Like that kind of sucks. So your calculator, unless it's, you know, stupidly expensive, such as mine, lots of calculators usually don't have the option of converting back and forth between mixed. One thing I will say, here's that stupid calculator, there it is. One thing I will say is that a lot of these calculators, you see that little A and then B over C button right there next to the LN on the third row? Notice what it says right above it, A, B over C, and then as a couple arrows, D over E. That button right there, once you figure out how to use it, can convert back and forth between mixed fractions and improper fractions. That is a good button to have. That is a good button. No, my freaking expensive calculator doesn't have that button. I have to find it in a menu. 150 bucks. Years after I owned it, somebody pointed out that I could, that second row on the left, that log button, you're not gonna see that at all in this class, but probably not till college algebra. But my calculator doesn't have that button. And somebody told me that if you press the diamond button on my calculator and the number 7, it popped up. And I'm like, what witchcraft is this? Why was this not written anywhere? I used the other one for so many years to get around it. And oh my God. Oh my God. So that was really frustrating. Yeah, seriously. Look at this number 7. You see the word log anywhere? No? Yeah, me neither. I press this button. I press that 7. What the hell? What the hell? What the hell? I press the button next to it. Nothing. Oh my freaking God. I never tried all the other ones. I just found a word root. I don't know what that does. Probably finds roots. Let's not worry about it right now. So let's say that you don't have that magical freaking button on your calculator. How do I do this? Well, you have a couple of options. You could say, if I don't have a calculator and I feel like hating my life a little bit, I could start multiplying out 15. I could say 15, 30, 45, 60, 75, 90. Hey, look, I bypassed that 86. So I'm betting it goes in 5 times, right? So you could do it that way. Or let's say you're lazy, like your teacher, and you're like, I don't want to deal with that. Let's type 86 over 15 in the calculator. So we end up with funky 5.7333333. Cool. What that's telling me is it goes in 5 times and some more. So 5 times that 15, that was 75. That's telling me 75 of this goes in evenly 5 times. So I could say, okay, well, that's going to be a 5. And then what's the fractional part of that? Well, if it was 75 coming in there, how much do I have left? So you kind of have to do some subtraction there. 86 minus 75, you would say, all right, I have 11 left. How many miles did you walk? Oh, 86 15ths. No, how many miles did you walk? 5 and 11 15ths. Splitting hairs there pretty quickly, but whatever. You're breaking down to 15th of a mile. That's fine. Out of my own morbid curiosity. Oh my God, that does go in evenly. That is 5 miles and 3,872 feet. Exactly. Apparently. All right. Hey, anybody know how many feet go into a mile? No? Cool. You're gonna. It's gonna take a few weeks for us to get there, but you're gonna. It's 5,280. Why do I know that off the top of my head? Because so many students have come to me for help with unit conversions. They're kind of annoying. We're going to do a bunch of them, but that's like a month away, so we're fine. Yeah, do we have any questions on this problem? Understanding it okay? I know it's rough right now. We're going to get you paired with the tutor. I know that's happening. Yeah. You're gonna fall behind in the class. Every single one of you, all of you online, all of you in person, you're all gonna fall behind in this class. I'm gonna tell you that right now. You're gonna be stressed. You're gonna be like, oh God, I don't know this. Everything's ruined. Yeah, ruined. Everything's gonna blow up. Literally, the whole idea here is we're throwing a lot of things at the wall and we're seeing what sticks. Because you know what? there's entrance exams for college math courses that you have to take anyway. You'll
that
get
is gonna be in the test, not the final test.
on the final stuff like this, yeah, probably. Oh yeah, stuff a lot uglier than this.
Um,
Yeah, I mean, let's, oh, you think you got to cry? I'm gonna show you something. All right, let's see here. Oh. Hello, book I hate. So I hate this book because I hate the organization. And also, I mean, this book is not written for students. This book is totally written for teachers who don't remember this stuff off the top of their heads. Because literally, like, that's all the book says on radicals and roots. And which page is this? Oh, this is in Unit 1, Lesson 1. Are we going to get to radicals in the first week? No, we're not going to. We're not going to play that game. But all the way back here is kind of the reason why I keep this book around. All the way back here is a practice test. Now, the practice test covers everything. Everything, because what's your test going to do? It's going to cover all of it, right? Now, the thing is, you're not going to get all of these skills from this class. I mean, I got 2 classes to get through, this one and the one afterwards, and I'm thinking that the one afterwards, I'm probably just going to do this practice test outright in the last week. So if you stick with me for 3 months, you're going to see me write down all of these. But there's a lot of stuff. A rectangular shaped floor measures 96 by 68. A flooring company is going to use ceramic tiles that each cover 2 square feet. Which of the following expressions represents the number of tiles that are needed for the floor? It's actually a really easy problem, but you don't know it right now, right? Cool. That's why you're here. So you get all of these things. Look at that guy. That looks horrible. That is 5 steps. We could do that in like 5 steps. I can actually do it by looking at it. Let's see, that's
your third power, right? For that radical, no.
that is a cube root.
So
That is 27, 20. The answer is 4. So you're gonna see things that you have no freaking idea on. And you're gonna be like, oh my God, I'm never gonna be able to do that. And yeah, no, you will. That's the thing. Because honestly, this problem is just stupid. I did that last class and I was like, God, this is just stupid looking. But these are the types of problems that you would see. Specifically, like I said, the high set test is all multiple choice. So you're going to be off to the side on scratch paper working out problems in order to figure out if you're going A through E. So that's kind of what's going to happen there. If you take the GED, sometimes you'll have to fill in a number, sometimes it'll be drop downs, but that's kind of how those guys are structured. So yes, you want to be able to get the idea down on all of these concepts, but I'm also throughout this class going to show you ways that we can kind of finagle and figure out nicer ways of dealing with things. Because I mean, honestly, most of that test can be aced by looking at the answers and cutting out the ones that end up looking stupid. So I'll teach you how to recognize that's kind of stupid. We're not even going to look at that. So it's going to make your life easier. It's very convenient having an incredibly lazy math teacher because I will show you all the shortcuts I have learned for all of the years, like the converting back and forth with these fractions. That's just one of them. Gabe is barely 2 3/5 years old. He has spent 1/3 of his life sleeping or crying. I know that feeling, Gabe. How much of his short life has Gabe spent either sleeping or crying in years? All right. So one of the skills we need is being able to pick out what it is we're doing with these problems. You know, the first one, that's pretty easy to look at. I mean, we had 2 1/3 miles on one day, 3 2/5 miles on the next day. How many miles did you walk in all? Well, we're just adding that, right? So this one, we have that, bless you.
Thank you.
This kid has an H, 2 and some change. And we have that we are looking for 1/3 of that, right? So we have to think, okay, what operation is going to give us 1/3 of this? Well, it ends up being multiplication. You're trying to figure out half of something, you would say half times that, right? So if I'm trying to figure out what 1/3 of this time is, well, I have to multiply it by 1/3. So you just write out the pieces that are useful. Personally, that's just kind of how I wrote it. But when you have a word problem, just write down how it makes sense, and you kind of like fall into your problem. So we have 2 3/5 years old. We're finding 1/3 of that. Because of that, we are going to say, okay, well, I need to be able to multiply these two numbers together, right? Well, now we have to be able to multiply those. Well, that 2 3/5 is going to throw a wrench in things, so we got to convert it to an improper fraction again. So take the 2, multiply it by the 5, so we have 10 plus 3, we have 13. It's still over 5. And that multiplied onto 1/3 is really easy, right? Because multiplying fractions is great. You just multiply straight across. 13 times 1, 13. 5 times 3, we've already done that today. That's 15, right? Now, this is a proper fraction, not a proper fraction, right? So do I need to convert back to an improper fraction? No, because the top is already smaller than the bottom. Improper fractions have the top larger than the bottom. So there's nothing I can really do here. This is a fraction, but that fraction represents what unit? Well, we were working with years old, and we're trying to figure out what 1/3 of that is. So this fraction is in years. Well, that was our question, right? It was asked, hey, how much has this baby spent sleeping or crying in years? 13/15. Now, if you hate yourself, you could totally figure out what that is down to the second. I'm not going to do that to you until we go over unit conversions in a month. Why do I keep bringing up random things like that? Because, hey, when I started tutoring, like I said, things started getting easier for me when I just looked at things. That's different pieces that I could figure out rather than separate classes. So if I can glean some of that into you, then that's my goal. Actually, now that I'm working on this, I remember, didn't I say I was going to show you a cheap way of doing the other one? I completely forgot. Let's go back to that. 2 1/3 and 3 2/5. So this was just number 1 again, but I'm going to show you something really cheap. 1 and is cheap. Because remember, when we were like, oh yeah, we have to add these, we have to convert them to improper fractions, blah, blah, blah. Well, what's my problem with with mixed fractions? That they're two separate things, right? That's another way to write the same thing. Well, hell, we just learned all about those commutative and associative properties. Why can't I add these two together? Oh, I can. That's the fun thing. When you stop looking at math as completely separate lessons and it's all just stuff that you can mess with, it works. Well, heck, now I can add these two fractions, but I don't have to convert anything, right? I could just put those together by getting a common denominator. Now that has the same steps as before. I'm gonna write it out again just because I didn't give myself a lot of room there. But I can do the same thing. I can multiply this one by 5/5 and this one by 3/3. But instead of some weird stuff where I get like 86 out of 15, what do I have? 5/15 and 6/15. Well, it's 5 and 6, 11. This is 5 plus 11/15. Well, what's my problem with my mixed fractions? That they're two separate things? This is a mixed fraction. Oh, look at that, I broke math. It's cheap, but it works. So if you're on a test and you have to combine mixed fractions and you're like, oh God, I don't remember what that weird dude was ranting about. You could at least remember that, hey, these are two separate numbers being added. You can totally just add them however you want. Because the commutative property is useful. Did they ever teach you that about the commutative property? No, but that looks like it might come in handy in the future, huh? That's not me like hinting at anything. That literally like sometimes you're just lazy and that's a way to do things. I have 100% been incredibly lazy about math work and made it work. And works out great. Okay, so let's look at number 3. Let's look at number 3. David ate 2 1/7 pizzas. Please seek help, David. And he gave 1 3/14 pizzas to his mother. How many pizzas did David have initially? So this problem is a terribly written problem that I threw together really quickly because it doesn't make any sense to not have complete pizzas at the end of this, but hey, whatever. Not everybody goes to the store and buys 40 watermelons, right? Okay, so I'm gonna write down things that are standing out to this. I mean, hey, I can't stop you. You need to go, you need to go. That's okay. Might be good to take a look at the notes later in the Google Drive. Because I just totally scanned the notes from last class all of 2 hours ago and put them up there. So, and this slideshow is in the Google Drive folder that I emailed out to everybody already. So no need to frantically write this too much. So I'm going to write down the things that are standing out to me that I need. So I know that I need that 2 1/7, right? And that's how much he ate. So I'm just writing on my paper here 2 1/7 he ate. He gave away 1 3/14. And it's asking how many pizzas did he have initially. So it's asking, hey, if he gave this away and he ate this much, how much did he have already? And you know what? I'm gonna edit this. I'm gonna edit this problem. We're gonna add a third point to this. He gave it to his mother. Let's do that. If he had full pizzas in the first place, how much is left over? Let's do that. So let's say you have a bunch of pizza. You made a bunch of pizzas, you got drunk, you went to Papa Murphy's, you just kept making pizzas. And then you're like, I don't need this much pizza. So you give one away and maybe an extra slice. But you only eat so much. So you only eat so much, then how much is left over? So what I'm going with is that I've literally just fixed my problem of not having full pizzas at the beginning. So we're going to play with this idea. Let's look at my notes. This is how I wrote it. You probably have a different way of writing it if you're figuring out a problem on your own. But yeah, that's just how I did. So I wrote down that he ate 2 1/7, gave away 1 3/14, and we're trying to figure out, okay, how much is that? And then how much did we have in leftovers? So if we ate this much and we gave away this much, then okay, to figure out what we had combined, we would combine them, we would add them, right? And yes, I just showed you a cheap way of doing this, but I'm totally not going to do it that way because, you know, I'm here to teach you the right way. Even if it's the cheap way, it's the right way. So we're going to convert this to improper fractions in order to be able to add them. So we're going to do 2 times 7 is 14 plus 1, 15. So we have 15 sevenths. Right. Then over here, this one's easy. 1 times 14. Gee, what is that? 14. All right. Plus that 3. That's 17 over 14. So I have 15 sevenths and 17 14ths, and I need to add these together. Well, those ones are really nice to get a common denominator, right? Because, well, this one's already half of that. So to get a common denominator, all I really need to do is multiply this one by 2 over 2 right there. And remember, we can multiply by 2 over 2 because it's a funky looking 1, and you can have 1 of anything and not break it. So this is going to be 30 over 14 plus 17 over 14 equals something over 14, because, you know, adding fractions, same denominator. 30 plus 17, that's going to be a 47. Okay, so we have 47 14ths. Not the nicest number, but we're going to have to convert that back into mixed fractions, right? So you might not remember how many times 14 goes into 47, but the calculator sure does. 3 and some change, right? So let's figure out what was that 3 times 14 there. 42. Okay, so 42 goes in evenly here. So that will go in, the 14 goes in 3 times, and that's 42 out of our 47. So we have 5 left over. Okay, all right. So that's how much we had initially, if I combine how much we ate and how much we gave away, right? But then I decided to change it because how much leftovers do we have? Because really, this problem didn't sit right with me, because who the heck cooks 5/14 of a pizza? Yes, sir.
So if you had full pizzas, because there's 3 and 5/14 less, you would have 4 full pizzas. So what would be left over would be 9/14, right?
Boy, howdy. Way to get ahead of me. I'm cool with that. But yeah, exactly. So the whole idea on what it is that we're gonna have as leftovers is me saying, okay, we're gonna round this up. And we're gonna say, okay, well, if I have 3 and change, that means that I had 4 pizzas initially. That's gonna be our leftovers. And yeah, you don't necessarily need to go to the trouble of converting this back to an improper fraction and converting this to a fraction and everything, because remember, this is the same as this. Oop. Ah, I just made a mistake. You know what my mistake was? My mistake is why I hate mixed fractions. Because this minus is not just attached to that 3, it's also attached to that 5/14. So if I did this, I would break math. I have to do that. I have to do that, which ends up being, now, remember the distributive property. I have a negative outside of here. That also counts as something to distribute. If you're confused by that, you can kind of look at this as being a -1 that you're distributing through, but that negative has to go to each of these. So we end up with 4 minus 3 minus 5/14. And then we can put the nice ones together. What's 4 minus 3? 1 minus 5/14. Well, you know, the nice thing about 1 is when I have to get a common denominator there, I can put it over a 1 and multiply by 14 over 14. And believe it or not, this 1 turns into 14/14 minus that 5/14. So what do we have left over? We have 9/14 of a pizza. Isn't that fun? Now, I don't know who the hell is slicing their pizza, so it's 14 slices per pizza, but you know, that's kind of weird. Yeah, I literally have pizza, leftover pizzas in my fridge that I'm probably gonna eat when I get home. I'm excited. Just gonna cover it in hot sauce.
The school pizza party, pizzas, cut it into small little slices.
Oh, God, yeah.
Yeah, like,
I work retail. I hate pizza parties now. You guys don't get a bonus, you get pizza.
I work too, so
I'm sorry.
you don't get a raise, you get a barbecue at the end of the month.
You know, I would take barbecue.
Well,
tired of
it's like poorly cooked burgers.
The last time I got pizza from GameStop, it was sponsored by Take-Two Interactive. So thank you guys who make Grand Theft Auto, because they bought us pizza, not GameStop. That company was too cheap to even buy its own employees pizza. And then you figure out how much regional management makes. You're like, oh God, you guys are jerks. All right. So we have one more big, ugly mixed fraction word problem left. So Emily needs enough fabric for 3 1/2 hats, and she has half a hat done already. If each hat requires 1 2/7 feet of fabric, how much fabric will she need to make 3 1/2 hats? All right. Well, again, this one ends up being multiplication, Because each and every one of these 3.5 is gonna need 1 2/7, right? We're going to have that many times. Not the prettiest fraction problem I've ever written. So what do? Well, the same as always. When you have a word problem with mixed fractions, you convert them to improper, do the math, and convert back. So 3.5, 3 times 2 is 6, plus 1, we have 7/2. And then 1 2/7. So we're going to do 1 times 7 is 7, plus 2 is 9. We have 9/7. Now, this is the first problem where I can actually show you something nice in terms of reduction, because, well, yeah, I could multiply across 7 times 9, and I can multiply it across down here, and it's 2 times 7. Now, this we end up being able to see these as kind of factors. Kind of bear with me for a second here. This is just me rewriting how it makes sense. What we have on top is going to end up with whatever 7 times 9 is. And what we have on the bottom is going to end up with whatever 2 times 7 is, right? Well, if you have a fraction, say 4/8. 4/8. Let's say we have 4/8. An example over here. And you said, hey, I can reduce that, right? What do? You say 4 goes into each of them, right? 4 goes in here once, 4 goes in here twice. Well, what am I doing? Kind of cancel, right? I'm kind of looking at this and saying they each have a 4 in common and they cancel. That's basically what we're doing when we reduce, is we're taking a common factor out of the top and the bottom and chopping it out. So we end up with our simplified form. Well, if I have 2 fractions multiplied by each other, and I can see that I have what's going to end up being the same factor on top and bottom, wouldn't this be reducible by 7 as well? Whatever I end up with here is going to reduce because it has a 7 on top and a 7 on bottom. So what you can actually do is do it now. 7 goes into itself once. 7 goes into itself once. So what do we have? We don't have 7/2, we have 1/2. Multiplied on 2, not 9/7, we have 9 out of 1. All right, that's a lot easier to do. Multiplying across, 1 times 9 and 2 times 1, 9/2. How many feet of fabric do we need? 9/2 of a foot. That doesn't make sense. So, if that doesn't make sense, we're going to convert it back to an improper, or to a mixed. You'd say, okay, 2 goes into 9 4 times with 1 left over. One thing you'll notice is that when it comes to word problems, even though I don't like the whole writing a full sentence thing, good to have the units on there. Good to have the units on there. We're dealing with feet. Earlier we were dealing with miles, so you'd actually write feet, you'd actually write miles. There we go. Questions, comments, concerns? I'd like to know why my chest hurts. Is it because I've been talking for over an hour and a half? I don't know. If I die, just drag me outside and let it happen. You didn't see a thing. Leave me in the room, close the door, it's all good. Not worried about it. So, you're good with fractions. We've done a lot of fractions. wants to do more fractions. Because I totally don't. I'm probably gonna just cherry pick some of these and call it good. I don't think we need them all. Liking number 1. Mm. 4. Oh yeah, and I'm totally doing number 6 because that's the weirdest looking one, right? It'll make more sense how I write it. Let's do those. That's how I wrote number 6. It's kind of a fraction divided by a mixed fraction, which we haven't done yet. It's ugly looking, so we're gonna do it. So for number 1, we have 10 and 1/9 times 4 1/2. Now, one thing I do want to point out is that remember earlier when I was like, hey, this is a cheap way of doing things and you could totally do it this way, and I split those up with a plus in the middle? That's not going to work for you here. That's 100% not going to work for you here. You could, but then it would become something you're very much not ready for in the realm of distributive property. You would end up having to multiply 4 things together. That doesn't sound fun. Let's make it easier, not harder. So we're going to convert these to improper. 10 times 9, 90, plus 1, 91 over 9, times 4 times 2 is 8, plus 1 is 9. We have 9 halves. Now 91 isn't going to clean up too nicely, but the same thing here is happening that happened on the last problem. These 9s can cancel out. One thing I do like to do is when I cancel things out like that, I like to put 1s because, well, 9 goes into itself once and 9 goes into itself once. You might look at that and say, why is he talking about this? I already know that. That makes sense. I wouldn't do that otherwise. Because the reason I'm doing this is because I have seen people cross the entire things out where an entire term just gets crossed out, and instead of them paying attention to that, it turns into a 0 instead of a 1. So that is a common mistake. And in order to keep myself and you guys from doing that common mistake, that's why I put those 1s there. Am I going to need to keep in mind that that 1 is there? I mean, it helps, 91 times 1. But really, what I can do when we start getting really good at these types of problems is we can look at this and say, okay, everything on top is multiplying together. What do I have that matters? 91. Okay, everything on bottom is getting multiplied together. What actually matters down there? The 2, right? Because anything times 1 is itself. So we don't really have to say, oh yeah, 1 times that, 1 times that. You don't have to think about it really. You can just say, hey, there's a 91 up top, there's a 2 on the bottom. Now converting this into a improper fraction or into a mixed fraction can be kind of funky. You can be totally cheap about this. You can go to your calculator, say 91 divided by 2, you get 45.5, and you could say, yeah, that's 45 and 1/2. You can do that. If it's a nice, neat little fraction down here, and you can say what that is from the decimal to the fraction, go for it. It's not the end of the world. It's another way of doing something that you already know how to do. If you don't know how to do that, you would just have to sit here and say, how many times does 2 go into 91? you'd go to the next even number, 90, chop it in half, you'd get the 45, and you'd say you'd have your 1 left over. So you still end up with the same number, just another way of looking at it. Okay? How about this ugly thing? I only picked this one because the numbers were ugly. And because it had a minus. None of these really had a whole lot of minuses so far, right? So if I had to convert this into an improper fraction, I have to know what 14 times 8 is. I have no idea, so we're calculating that. Hello, Mr. Calculator. I get 112. So 14 times 8 is 112. Plus that 1, that's 113. So we have 113 over 8 minus, let's convert this guy. So 4 times 7, that's 28, plus 5, we get 33. This one's got some ugly numbers, right? What I noticed that gives a lot of people anxiety when we're doing these problems is that the bigger the numbers get, the more scared people get. But it's just a number. 113, in terms of things that we have to multiply and divide and all of our operations, the same as having like a 2. We're still going to just use it as we use it. All of the rules still apply. We have 2 fractions. They're being subtracted, so we need a common denominator. Between 7 and 8, I don't know. If I multiply 7 and 8 together, I get 56. So that's probably going to be a common denominator, right? We can kind of look at this. We have an 8 and a 7. I'm going to multiply this one by 7 and this one by 8. So we got 7 over 7 and 8 over 8 next to each other. And now I can see on the denominator, they both have a 7 and an 8. So we know that we have a common denominator. But we got ugly numbers, right? So I get something with a 56 minus something with a 56. What is it? I don't know. What's 7 times 113? Again, no idea. Go to Mr. Calculator. Mr. Calculator says it's 791. Just a number, just throwing it there. Good enough. Okay, what's 33 times 8? Again, no idea. 264. You can now see why they let you have a calculator. Because, I mean, nobody's going to expect you to sit here and multiply these numbers out on paper in order to just get your one next step. So, yeah. What is this? I have no idea. Again, calculator. 791 minus 264. I get 527. Okay, so that's still out of 56. Oh man, we got to convert that back to a mixed fraction? Oh, that sucks, right? That's a weird looking one. But the exact same rules apply. It doesn't matter what our numbers are, the exact same rules apply. So we always look at this and we say, okay, how many times does that go into that? I have no idea off the top of my head, neither do you. Actually, I do, it's 9. Main reason being, if I multiplied this thing by 10, I'd be at 560. So probably one less than that. So I'm betting 9. So we try the calculator. We say 527 divided by 56. 9.410. This thing actually just rounds to that point. But yeah, weird fractional thing, right? Weird fraction thing. All I care about right there is that 9. That 9 tells me that that 56 went in there 9 times evenly. So what was that? 56 times 9 is 504. Now this one's getting a little complicated, right? We got some big numbers and we're having trouble keeping track of them. So let's let's split this up a little bit. Let's draw out this number a little bit longer, because normally this is where I'm like, oh yeah, here's our answer, right? So what I'm going to do is I'm going to split it up, and I say I have 504 plus, I don't know, over 56. So if we want to know, because remember, we're doing the kind of the part that goes in evenly and then the part that doesn't. So we just figure out what the difference is between the 527 and that 504 that we just figured out went in evenly, and we find that it's 23. So I'm writing it this way because we're just trying to keep things straight, and we're saying, okay, I just figured out this is how much goes in evenly, and this how much doesn't. So now, if I split it up, I would say, okay, this right here, the 504 over 56. Oh, and by the way, this right here is completely and totally equivalent to this. I was just kind of skipping that step, but that is completely equivalent. If I'm doing this, I can split it up as this over that plus this over that. That's fine. So this part right here, that's a 9. We figured out it went in 9 times. And then we have 23 over 56. I don't think 23 over 56 reduces. What do you say, calculator? Hey, look, 23 over 56 is 23 over 56. And you know what? If 150 bucks told me that, then I'm gonna trust it. So it doesn't reduce. We have 9 and 23/56 right there. Now, yeah, that was a long problem, but it followed the exact same rules that everything else did. We had 2 fractions being subtracted. We got a common denominator between them. We subtracted the tops, and then we took what we had as an improper fraction, and we took a couple of steps to convert it to a proper fraction, to a mixed fraction. There's another reason why I hate working with mixed fractions, because I totally would have gotten to this thing and been like, yep, that's it, we're done. You get to calculus, you get to college algebra, you get to pre-calc, whatever the heck they're calling it nowadays. You get 527 over 56, you put a box around it, you're like, cool, that's the answer, good enough. You don't have to do all this. Okay. Now we got this weird thing. I got a proper fraction being divided by a mixed fraction. Fractions. Okay, well, this one I don't have to mess with a whole lot. But this guy's kind of messy, right? So what we're going to do, I'm going to take that 2, multiply it by the 15. So we have 30 plus 6, 36 over 15. And remember, the slash is the same thing as having a division symbol. Same thing. Are you going to get to a higher level math and see slash instead? No, you're going to see big, ugly, complex fractions. They're not going to write it this way. They're not going to use that. They're going to give you this problem and tell you to do it. But it's okay, because again, dividing a fraction by a fraction is kind of stupid. We don't like the idea. So we're going to leave that top one alone. And then we're going to flip the bottom one and multiply. Now remember that reducing I did earlier, the canceling? We could still do that if it's just parts of the number. Because what I'm noticing right away is that at the end of this, I'm going to have a 15 on top and a 5 on the bottom, and those reduce. I have a 3 on top and a 36 on the bottom, and those reduce. So why don't I just do it right now? 5 goes into itself once and into 15 3 times. Awkwardly enough, you could totally just use those 3 and 36 now if you wanted to. I'm not gonna because I already decided I was gonna do that, but just so you know. So this 3 goes into itself once and it goes into 36 12 times. And this is why I put those ones, because I've seen people cross these out, say this is 0, multiply it by that, and then you end up with a 0 because you have 0 times a big ugly thing. So what do we end up with? Well, we end up with 3 12ths, which still reduces, right? 3 goes into itself once and into 12 4 times. This whole big ugly thing, 3/5 divided by 2 and 16/15 ended up being 1/4. Didn't know it was chopped off there. My bad. That whole thing ended up just being 1/4. Isn't that fun? No, it's not fun. Yeah. But it's good to have that skill under your belt, because one, if you didn't know what to do, you would look at this and be like, oh God, what? And freeze. Well, no. What you have to do is you have to change that to multiplication. You have to flip and multiply. Now, we could have just multiplied across. If you're in a test and you multiply straight across on that and you start reducing and you're like, I could have done that earlier. You don't have to erase everything and go back. You could just fix what you have. The downside there is if you hadn't done that, you would have ended up with 45 over 180, and you would have had to reduce that, right? Because that's what you would have ended up getting if you didn't reduce. Now, that works out fine because 45 goes into itself once and into 184 times, but you're going to end up sitting there for a minute figuring that out, right? So reduce earlier and do less work.
Now, only this can do on a division and
With the canceling,
yeah, the reducing.
so the reducing, the canceling, that can only happen when you are, I'm not even going to say division, I'm going to say only multiplication. Because you can do it at division, but it's going to be weird. So wait until it's already multiplication. But when you are multiplying the fractions across, that's when you can reduce. I couldn't reduce, say, up here when I was doing this fractions. You can't do that because those are solid numbers. This is some amount minus some amount. But what we have here is, you know, this is multiplication. It kind of ends up being one number because of how it sits on the order of operations. Remember, I used the additions and subtractions as separators. It means everything in between is kind of like its own deal. So this is kind of its own thing because, write it anywhere. Because of the concept I covered a little bit earlier.
So when you do reduce the bottom and top, it's not just side by side, right?
Yeah.
So if
it
you
has
have to
to
do
be-
with 515 or.
Yeah, exactly.
Top and bottom.
Because the entire idea is this guy right here. We know that when we multiply across, what we end up with on top is going to be whatever the heck was on top together. What we end up with on bottom is going to be whatever the heck we end up with, we started with on bottom multiplied together. So you know for a fact that your factors on top are going to end up on top. Your factors on the bottom are going to end up on the bottom. So if you have something you can reduce before you figure out what the larger numbers are. You can absolutely do that. So that's why it's safe in multiplication, but nothing else, because 7 times 9 is some number and 2 times 7 is some number, and we know they both reduce by 7. So why am I going to figure out what those big ugly numbers are if I know I'm going to chop that 7 off anyway? Just do it now. It'll make your life easier. All right, guys, are we having fun? You all look dead inside. And beating all of you to the dead inside thing.
Have to get out early, or fitting one.
Luckily, today's my Saturday, kind of. So even though I'm here teaching for 2.5 hours, I didn't have to work this morning. So I absolutely got up, played a bunch of video games, took a nap, and came here. Showering happened at some point in there, but we're not going to talk about where.
We're gonna work a day.
At the Griffles Plasma Donation Center over by Target. Yeah, they hired me on as a phlebotomist, and I'm like, I've never done anything in the medical field at all.
They hired you, wow.
Yeah, well, here's the scary part. They require a high school education. That's it.
Are you serious?
Literally, any of you could take that test and then take it down there and be like, cool, train. So, yes, my math degree came in completely uselessly. I think only one or two people I've worked with have worked at a hospital and been formally trained in phlebotomy past that. But yeah, it's all on the job training, tons of tests, tons of memorization. And then it's like, all right, time to start sticking donors. And that is terrifying. It is terrifying.
You have to take the blood out. Very good.
So, yeah,
No, you do that?
yeah, let's complete, oh, it is. Yes, I have all kinds of anxiety problems. I hate even standing up here and talking to a bunch of you. So imagine, why is anti-drug propaganda, who's Googling anti-drug propaganda? Yeah, right. Who Googled Google Slides?
So click on that real quick. I want to see what
You know what, yeah,
what comes up, please. Wow.
the most powerful anti-drugs ads of all time. If this doesn't have that woman in the 90s smashing her kitchen with an eggs and the stuff there. Yeah. Yeah. Yeah.
Your brain. This is heroin.
I did not know that was Rachel A. Cook. Thank you for Josie and the Pussycats, Rachel A. Cook. Smash it, smash it. Okay, that's cool. Let me get to the,
Do not believe you even know that actress. Wow.
well,
That was during my time in high school.
huh? How old are you?
Dude, I'm 50.
Yeah, I am 36. Yeah.
Before you guys.
It's definitely before mine, but
Yeah.
still in the class next to them.
Yeah, that was one of my crushes growing up, so there we go.
Yeah, no. One had a crush on her.
Yeah.
Oh, man.
Yeah, because she was, they made that was like the beginning of the teen movies in the 90s.
Yeah.
Was all that, and it's like, look at her, she's ugly. She's wearing overalls and she has her hair in a ponytail and she has glasses on. Oh God, but if you put her in a dress, she's beautiful. Wow.
Cut her hair and keep your eyebrows.
Yeah.
No, it
Like-
was like the big thing in the 90s.
Yeah.
And
And then
before
American,
that, the hair was this high
oh God.
in the 80s, the late 80s.
The hell was I doing again? Where was I?
You should know. Remember that spray hair? Girls over like, whoa.
All right. I forgot where I was going.
You were searching by the blood, what you do.
Oh yeah.
Not searching by the
So
blood.
I use these things.
Dialysis, no?
Nah.
Okay.
What are you? Go away. You. Are you a big? Okay, cool. I don't want, that's a terrible picture. Here's a useful thing. Let's go. Tools, size, large. That thing.
Okay.
Yeah, so all the tubing and everything is disposable, so every time I talk to somebody and then set them up, I have to put all of this tubing on here, the anticoagulant down there, the saline up there, and we don't have pouches, we have like a plasma bottle down here. But yeah, I hook them up to this thing and then it's a plasmapheresis machine, which I didn't know was a word until like 2 months ago. But it takes out all their blood, it pushes it to the separator up top here, and it kind of spins like a centrifuge. And it separates the plasma from the red blood cells, and then it puts the red blood cells back.
That's his body?
Yeah. So, and it does that like 6 or 8 times or something like that. However, it depends on how hydrated you are. But once it's done with that, you have a full plasma bottle down here, and you have all your red blood cells anyway, and you get a bunch of saline in you. And every once in a while, somebody starts feeling dizzy. I've seen some really kind of bad reactions, but I think honestly, like 90% of it is people psyching themselves out. One guy like started throwing up everywhere, and that needle was
Oh, thank you.
maybe like 2 millimeters in his arm. Like if you have a splinter, every splinter you've ever had in your life has gone deeper than the needle was in this dude's arm. And he lost it, and it happens. It's just something you psych yourself out on. But yeah, in order to pull that off correctly, because you're pulling blood out and putting things back in, it's like a 16 gauge needle, and you have to perfectly get it into the vein. And I hate that. That is not a skill I have. I've been told that I'm doing really well and my yield is almost perfect, and like if the level of confidence I have right now is me doing
I
great.
just don't like needles. No, I just don't like needles. Yeah,
I don't like eating needles either, which is hysterical because I'm putting them in people's arms.
yeah.
So, I don't know. I don't like it. On Saturday I'm getting cross-trained in the plasma processing lab, and like 90% of that job is packing. Because I am getting, since I had 10 years, over 10 years of customer service experience, I'm only making about 17, but that is more than I've made elsewhere. I mean, this job pays better than that, but I only get paid for class hours. None of these slides I got paid for making. Hundreds of slides. So I figured out, because people who are return donors, they get $40 per donation. You can do it twice in a week, and if you do it the second time in a week, you get a $30 bonus. So it's 40 and 7. That's 110. Well, I make 22 an hour, and I'm in here 5 hours a week. That's 110, but I get taxed and they don't. People sitting there on their phones getting their blood pulled and everything in about hour and a half a week are making more than me. Sweet. All right. Math. I did the math on how. Yeah, it's interesting. I'm just like, it freaks me out. I got one coworker who's like, all right, let's do this. I love this. Just excited out the gate. He's like, let's do some needle sticking. And I'm like terrified every single time.
Right.
Terrified. Because I'm like, I've had the bad things happen. I've had the bad, as far as I can tell, it doesn't matter how you go to good yard. You ever been to a hospital and they can't find your vein, they just keep jamming you and you end up with like I guarantee you that I guarantee you the nurse you complained about was the best nurse somebody has ever had. It does not matter how good you are at it, you are going to make mistakes. So I have gone through a few veins. And it works for the draw, it pulls out blood, you got blood in there. But when it tells you when it starts putting it back and it doesn't go in the vein, and you end up with this giant thing on their arm,
Oh my God.
I'm like, run, pause, ice pack. Terrifying, and you feel awful. You feel awful. Yes, you feel awful. Yeah, it's that. Yeah, I have to take a bunch of anxiety meds before I go. All right. How long have I been rambling? Like 15, 20 minutes? 10? Been counting? All right. Okay, that's
11
fair.
now.
I'm trying to take a little bit of the pressure off. Because, everybody's brains started turning to goo. I saw it. You know what else pisses me off about most math teachers? They skip a lot of steps. Because when you're learning something new, you forget how to add. You have no idea, like, how the hell did you get that? Just added them together. Cool, show them. The brains are goo. So, the next slide that I've had up for a while, and probably everybody's had time to look at and ignore, just talks about ratios. And we've already kind of touched on the idea of ratios because rational numbers are literally anything that can be written as a ratio. And I said, ratios are just another word for a fraction. So they're commonly written a couple of different ways. They can be written 2 to 3 with a colon, 2 to 3, or as a fraction, 2/3. Personally, I prefer them as a fraction. I don't like using the colon for these because usually that turns into like betting odds. And I don't like it when you're doing something in math and one thing means 2 different things depending on the context. I don't like that. I like it to be nice and clear cut, and everything I write has to be able to be applied to that one thing, and nothing is confusing. So when it comes to me doing ratios, you're going to see fractions. So that's why I stuck it with fractions. So this is just an example. A soccer team can have 11 players on the field at one time. One formation has 2 forwards, 5 midfielders, 3 defenders, and 1 goalkeeper. I knew none of that. I just copied this off the internet. What is the ratio of midfielders to the total number of players that a team can have on the field? So you would write that as a ratio. You would say, okay, you have the midfielders to whatever the total players is. So you'd say, okay, there's 5 midfielders, and you'd have 11 total players. So it's 5 to 11 with a colon, or 5/11, or 5 to 11 with the word 2. And that's pretty much it. That's what a ratio is. That's how it makes sense. I mean, that's all we got. That's what ratios are. Whoop-de-doo. I don't think I actually have any problems specific to that. Next thing, unit rates. And I have a wonderful Star Trek cap from just no context. I watch Star Trek, I'm sorry. But this is from the cringiest episode that exists because yeah, she gets really excited about a particularly erotic chapter in her grandmother's journal. That's messed up. That's messed up. The episode's weirder than that. So a ratio can also be thought of as a rate. I always like to use the example of miles per hour. That's a rate. That's a ratio. If you're going across town, if you're going 5 miles and it takes you 20 minutes, you would be able to say how many miles per hour you were going, right? You were going, 5 miles, 20 minutes. That's a third of a mile. So flipping, multiplying, you'd be going 15 miles an hour. Terrible example to blow off the top of my head. But yeah, it's as simple as saying if a tub is filling at a rate of 10 gallons every 2 minutes, the unit rate is 5 gallons per 1 minute. Unit rates are incredibly useful because it's comparing an amount of one thing to a single amount of another thing. Miles per hour. I don't know. I got nothing. My brain's good. But yeah, there's a bunch of different useful unit rates. If you ever go to like, I don't know, I know they're on the labels at Walmart, but if you ever go to Walmart and you see you see the price on the tag, and then there's like an orange price in the corner of the tag, and you've always ignored it. Well, that's the unit price. Usually that might be in cost per ounce or something like that. And you would be able to figure out what's cheapest by saying, hey, if I'm comparing this product to this product, well, the cheaper one, cost-wise, is going to be the one with the lowest amount per ounce, right? So that's comparing unit rates. Really useful. Rambling on while people were right. So, yeah, unit rates end up coming back to us in about a month. Remember I talked about rate conversions and stuff. Unit rates are the most useful thing when you're converting between different units. Let's look at some examples. A car travels 420 miles on 15 gallons of gas. Express this as a unit rate. Okay, so when I wrote this initially, and I've kept this the same for a couple of classes because I like how it works out. When I wrote this initially, you can kind of tell that I was shooting for an answer of, miles per gallon, right? But it ended up working out kind of nicely because you can look at it as two separate things. So we have 420 miles for 15 gallons. I'm going to show you how quick these are. Let's say I was looking for miles per gallon. Miles per gallon. How would I do that? Well, it's a ratio. It's a unit rate. It's a fraction. So I would write 420 miles being divided by 15 gallons. And what ends up happening is it doesn't matter if this goes in evenly or not. I don't remember if this does 420 divided by 15. It does, cool. So this ends up being 28, but our units are still there, right? This is miles over gallons. So this ends up being miles per gallon. Now, I like this problem because we could also figure out how many, like, let's say you were really hurting on money, and gas costs money, and you have to go a certain amount of miles in your day, and you're going to the gas station with pocket change and trying to scrape by exactly how much gas you're going to need. Well, then you could do gallons per mile. You could figure out quite easily how many gallons of gas your vehicle uses for every mile that you go. Then you'd be able to say, okay, well, if I'm going 3 miles, I can multiply it by 3. So this way you would end up just the other way around. Punch it in a calculator, get some horrible looking decimal, decide that you don't care about the horrible looking decimal and that's the answer. Whatever, I don't care, it's a number. And that's gallons per mile. And you would be able to actually use that and figure out, well, exactly how much money it would cost you to go for a certain distance. So, unit prices can come in handy. Unit rates can come in handy. see. I think I will save number 3 for reviewing on next class. So let's look at number 2. Then we'll probably call it good. I made it halfway through my slideshow today. Not bad, not bad. The last one was 45 slides. This one was 28. Okay, so this one, a grocery store is having a sale on crackers. A customer can buy 3 boxes for $5. Using this rate, what would be what would 5 boxes of crackers cost? All right. So at this point, first of all, we have to think, okay, what's our unit rate? What are we doing? Well, we're talking about cost per box, right? So that's exactly how we're going to set up our fraction. We're going to look at this and say, okay, our cost is $5 for 3 boxes, right? So we know that what we end up with is going to have a dollar sign in front and it's per box. So we do 5/3, throw it at a calculator, see what happens. 1.6666666, it's 2/3. Goes in once, and there's 2/3 left over. So it kind of goes on forever. You can write it with a little bar over it. I'm just gonna, for funsies, write a bunch of different ways you can write this. But we're talking, right now we're talking about dollar amounts, right? So if you're talking about dollar amounts, you usually round to the nearest cent. So that would be $1.67, right? This is going to be $1.67 per box. All right. So if I need to know how much 5 boxes is going to cost, that's easy, right? We know how much each box costs. We just multiply it by 5. $1.67 times 5. I get $8.35. All right. That's not too bad, right? That's an application of unit rates. I technically have enough time for the next one. I don't want to be here, and neither do you. So, hey, I'm tired. I don't know. I'm hungry. I have leftover pizza. I love drenching it in like hot sauce. I am a hot sauce person. But if we take a look at number 3, just as a glance, Spice Company offers different prices depending on how many ounces of each spice a customer buys, which the following is the most affordable spice to buy per ounce. So conceptually, not actually going to work it out right now, but conceptually, you have a bunch of different prices, you have a bunch of different ounces on amount. So to figure out what the best buy is, you would figure out the price per ounce on each product and compare them, right? That's what we're going to do probably about 15 minutes into the next class on Tuesday. Because right now I am done. I am totally done. I've been talking for 2 hours and 25 minutes. Throat hurts. I want to give it pizza. So yeah, you guys are free. You're done. Good. If anybody needs anything, shoot me an email, bother me. I am all for it. And